Okay, given this graph, we should be able to look at it and compare and say what's different from F to G. So it looks like F is the bolted in one, and G is the lighter one in the background. Or I'm sorry, I got that backwards. F is the lighter one, which I marked in red, and let's do it this way. G is the bolded one. Okay, so we've got lots of, if we think about the way a function is set up, a trig function, both of these look a little bit more like cosine graphs to me, although they could be sine graphs. So we often have a number out front, a number next to x. Sometimes we add or subtract to x, and then usually we have, or sometimes we have a number out front being added or subtracted, or at the end added or subtracted. So this would shift the whole graph up or down, and it looks like F and G both have the same amount of graph above the x-axis as below the x-axis. So I don't think there's any vertical shifting going on here. Also, it looks like the high points and the low points are occurring at the same time. So I'm going to say that there's probably not any vertical shifting going on here. Starting from here, it looks like you have to travel about 2 pi to see a full cycle of this. And starting here, it looks like it takes about 2 pi to see a full cycle. So a different value of b would change the period. So all that really leaves then is amplitude, and that's what we've got going on here. Amplitude is a way to describe how far up and down your graph's going. The definition is amplitude is half the distance between the min and the max. So like this one, the distance between the min and the max is 2, so half that distance is 1. So it has an amplitude of 1. And then G, the distance between the max and the min. See, 1, 2, 3, 4, and then half of that makes it 2. So I would say the difference between F and G is that G has twice the amplitude of F, or a little more concrete would be to say F has an amplitude of 1 and G has an amplitude of 2.